Hi all, welcome to Easy Max by everyone. You are learning integration. Let's see what we will cover in today's lecture. The topics that are covered in this lecture are a quick recap of previously learned concepts, solving few sums based on the standard results or theorems which we have learned in our previous lecture. You have learned three theorems in our last lecture. The first one was d by dx of integral f of x dx equal to f of x. The second theorem was integral k times f of x dx equal to k times integral f of x dx. And the third theorem was integral f1 of x plus f2 of x dx equal to integral f1 of x dx plus integral f2 of x dx. The second part is integral f1 of x minus f2 of x dx equal to integral f1 of x dx minus integral f2 of x dx. These two theorems can be collectively expressed and generalized as integral k1 f1 of x plus or minus k2 f2 of x plus or minus etc. plus or minus kn fn of x dx equal to k1 into integral f1 of x dx plus or minus k2 into integral f2 of x dx plus or minus etc. plus or minus kn integral fn of x dx. Let's see solving few sums using these theorems. Let's solve this sum integral 3x square dx. The formula which we are going to use in this sum is integral x power n dx equal to x power n plus 1 by n plus 1, and the theorem which we are going to use here is integral k times f of x dx equal to k times integral of f of x dx. So taking 3x square dx, we can take out the constant, k is 3 here, 3 times integral x square dx. And using the formula with n equal to 2, we have 3 times x power 3 divided by 3 plus c, the constant of integration. Further reducing, we can cancel these two 3's. So the final answer will be x power 3 plus c. Let us solve integral of 2 to the power of x plus 3 into dx. First of all, we are going to use this class of exponents. A power m plus n can be written as a power m into a power n. After that, the theorem which we are going to use in this sum is integral k times f of x dx equal to k into integral of f of x dx. Let us take the given sum 2 to the power of x plus 3 dx. We can split this with the laws of exponents. 2 to the power x multiplied by 2 to the power 3 times dx. This can be further written as 2 to the power x times 8 into dx. Of course, you know to the power 3 is 8. Now, this 8 can be taken out using the theorem integral of 2 power x dx. Hope you remember the formula integral of a power x dx. The answer for this is a power x divided by log a. So, using a equal to 2, we get 8 times 2 to the power x divided by log 2 plus c, where c is the constant of integration. Let's solve this sum integral of 5x power 3 plus 2x power minus 5 minus 7x plus 1 by root of x plus 5 by x times dx. The theorem which we are going to use here is the generalized version of the theorem 3, And the formulas which we are going to use in this sum are integral x power n dx equal to x power n plus 1 by n plus 1 and integral 1 by x dx equal to log x. Let's see how to solve this sum. We can split this integral into individual integrals. Integral 5 x power 3 dx plus integral 2 x power minus 5 dx minus integral 7x dx plus integral 1 by root x dx plus integral 5 by x dx. Taking out the constant terms from each of these integrals, we get 5 times integral x cube dx plus 2 times integral x power minus 5 dx minus 7 times integral x dx plus this root of x is x power 1 by 2 and taking it to the numerator we get x power minus 1 by 2 dx plus 5 times integral 1 by x dx. And further reducing we get 5 times x power 3's integration is x power 3 plus 1 by 3 plus 1 plus 2 into x power minus 5's integration is x power minus 5 plus 1 by minus 5 plus 1 minus 7 into x is x power 1, right? So x power 1 plus 1 by 1 plus 1 plus x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus 5 into log x plus c. Further reducing we get 5 into x power 4 by 4 plus 2 into x power minus 4 by minus 4 minus 7 into x square by 2 plus x power 1 by 2 by 1 by 2 minus 1 by 2 plus 1 is plus 1 by 2 plus 5 log x plus c. We can simplify this like 5x power 4 by 4. 2 divided by minus 4 will make this term negative. Minus x power minus 4 by 2 minus 7x square by 2. This 2 will go to the numerator, right? So this will be 2 times x power 1 by 2 by 1 we need not write plus 5 log x plus c. We can bring this x power minus 4 to the denominator to make the power positive. So finally we can write this like 5x power 4 by 4 minus 1 by 2x power plus 4 it becomes, right? Minus 7x square by 2 plus 2 into root of x plus 5 times log x plus c. Solve the next sum. Integral of 3 into sin x minus 4 cos x plus 5 secant square x minus 2 cosecant square x into dx. And the formulas which we are going to use in this sum are integral sin x dx equal to minus cos x, integral cos x dx equal to sin x, integral secant square x dx equal to tan x, integral cosecant square x dx equal to minus cot x. First we can split these values into individual integrals. We get integral 3 sin x dx minus integral 4 cos x dx plus integral 5 secant square x dx minus integral 2 cosecant square x dx. All the constants we can take out using theorem 3 is generalized version. 3 times integral sin x dx minus 4 integral cos x dx plus 5 integral secant square x dx minus 2 integral cosecant square x dx. And 3 into integral of sin x dx is minus cos x, minus 4 into integral of cos x is sin x, plus 5 times integral of secant square x is tan x, minus 2 into integral of cosecant square x dx is minus cot x, plus constant of integration. Simplifying this further, we get minus 3 cos x minus 4 sin x plus 5 tan x, minus into minus will become plus 2 cot x plus c. Let's solve another sum. Integral of 1 minus x into 2 plus 3x into 5 minus 4x dx. Now these three are individual algebraic expressions. So we don't have any direct formula support for this type of sum. First we have to multiply these expressions and make it a simple expression, or rather like a simple polynomial, and then only we can use the formulas to simplify this further. So first let us multiply these values. 1 minus x into 2 plus 3x equal to 1 time 2, 1 time 3x minus x time 2 minus x time 3x. This will be 1 into 2, 2 plus 1 into 3x is 3x minus x into 2 will be minus 2x minus x into 3x will be minus 3x square. Simplifying this further, we get 2 plus 3x minus 2x is x minus 3x square. Now we need to multiply these two by one more expression. So 1 minus x into 2 plus 3x into 5 minus 4x is equal to, the answer of the first two's product is here. So let us take it here, 2 plus x minus 3x square times 5 minus 4x. Again using the same product rule of algebraic expressions, we get 2 into 5 is 10, 2 into minus 4x is minus 8x, plus x into plus 5 is plus 5x, plus x into minus 4x is minus 4x square, minus 3x square into 5 is minus 15x square, minus 3x square into minus 4x will be plus 12x power 3. We need to simplify this further. 10 minus 8x and plus 5x will give minus 3x. Minus 4x square minus 15x square will give minus 19x square plus 12x power 3. Therefore, integral of 1 minus x into 2 plus 3x into 5 minus 4x dx will be equal to integral of 10 minus 3x minus 19x square plus 12x power 3 into dx. Now splitting this into individual integrals, we get integral 10 times dx minus integral 3x dx minus integral 19x square dx plus integral 12x cube dx. Taking all the constant terms outside, we get 10 into integral of dx will be x minus 3, integral of x will be x square by 2 minus 19 times integral of x square will be x power 3 by 3 plus 12 into integral of x cube will be x power 4 by 4 plus c. Further reducing this, we get 10x minus 3x square by 2 minus 19x power 3 by 3 plus 4 and 12 can be cancelled, 3x power 4 plus c. Let's solve this sum. Integral of 3x power 4 minus 5x power 3 plus 4x square minus x plus 2 divided by x cube into dx. Now we have to divide each and every term in the numerator by x cube, and after that we can split this integral into individual integrals. So first we will divide each term in the numerator by x cube. We will get 3x power 4 by x power 3 minus 5x power 3 divided by x power 3 plus 4x square divided by x power 3 minus x divided by x power 3 plus 2 divided by x power 3 into dx. Simplifying further, we can cancel 3x terms, so we will be ended up with 1x. Here x cube entirely cancels. Here there will be 1x in the denominator. Here there will be 2x terms in the denominator, like that. So writing the simplified version, we have integral of 3x minus 5 plus 4 divided by x minus 1 by x square plus 2 by x cube into dx. Now we can split this into individual integrals. Integral 3x dx minus integral 5 dx plus integral 4 by x dx minus integral 1 by x square dx plus integral 2 by x cube dx. We can write this x square in the numerator like x power minus 2, and this x cube we can take to the numerator and write it as x power minus 3. Let's do that and take the constants also outside. So we get 3 times integral x dx minus 5 times integral dx plus 4 times integral 1 by x dx minus integral x power minus 2 dx plus 2 times integral x power minus 3 dx. Simplifying further, we get this is equal to 3 into x square by 2 minus 5 into integral dx is x plus 4 into integral of dx by x is log x. So this will be 4 log x minus x power minus 2's integration will be x power minus 2 plus 1 by minus 2 plus 1 plus 2 times x power minus 3 plus 1 by minus 3 plus 1 plus c. Simplifying this further, we have 3x square by 2 minus 5x plus 4 log x. This term's denominator has a minus 1. That minus will change this minus to plus. So we have plus x power minus 1, which can also be written as 1 by x. Here this denominator has a minus 2. That minus will change this plus to minus. So minus 2 divided by, that minus we have taken, right? So 2 divided by 2, 2 and 2 get cancelled. X power minus 2 we will get. That can be written as 1 by x power 2 plus c. Let us solve this sum. Integral of x square plus 1 by x square whole power 3 dx. We have to use the formula for the expansion of a plus b whole cube, which says a plus b whole cube equal to a cube plus 3a square b plus 3ab square plus b cube. Using the same expansion for x square plus 1 by x square whole cube, we get x square plus 1 by x square whole cube equal to x square power 3 plus 3 into x square's square into 1 by x square plus 3 into x square into 1 by x square whole square plus 1 by x square whole power 3. Further simplifying this, we get x square whole power 3. If there are 2 powers, we have to multiply them. So x power 6 plus 3 into x square whole square will be x power 4 into 1 by x square plus 3 into x square into 1 by x square whole square is 1 square by x square whole square, which will be 1 by x power 4 plus 1 by x square whole cube will be 1 cube by x square cube, which will be 1 by x power 6. Further simplifying this, we get x power 6 plus we can cancel 2x terms here. So we will be left with 3x square plus here also we can cancel 2x terms. So there will be x square in the denominator, 3 by x square plus 1 by x power 6. So this is the expansion of x square plus 1 by x square whole cube, which we are going to use here. So this integral becomes integral of x power 6 plus 3x square plus 3 by x square plus 1 by x power 6 into dx. Splitting this into individual integrals, we get integral x power 6 dx plus 3 times integral x square dx plus 3 times integral 1 by x square can be written as x power minus 2 dx plus integral 1 by x power 6 can be written as x power minus 6 dx. Simplifying this further, we get x power 6 plus 1 by 6 plus 1 plus 3 into x power 2 plus 1 by 2 plus 1 plus 3 into x power minus 2 plus 1 by minus 2 plus 1 plus x power minus 6 plus 1 by minus 6 plus 1 plus c. Simplifying this further, we get x power 7 by 7 plus 3 into x power 3 by 3 plus 3 into x power minus 1 by minus 1 plus x power minus 5 by minus 5 plus c. Simplifying this further, we have x power 7 by 7 plus these two 3's will cancel out. So we will end up with x cube. Having this minus 1 in the denominator, we'll change this plus to minus. So minus 3, x power minus 1 can be written as 3 by x. And having a minus 5 in the denominator, we'll change this sign to minus. This x power minus 5 also can be taken to the denominator. So we can write it like 1 by 5 times x power 5 plus c. Let us solve this sum, integral tan square x dx. There is no formula support directly for this, but we can use the trigonometric identities to solve this. We know well that tan square x equal to secant square x minus 1. Using this identity here, we can write this integral as secant square x minus 1 into dx. Now we can split this into individual integrals like integral secant square x dx minus integral 1 into dx is just dx, and we know that integral of secant square x dx equal to tan x and integral dx equal to x. So this can be reduced to tan x minus x plus c. Let's see the next sum. Integral cot square x dx. In this sum also, we don't have any formula support directly, but we can make use of the trigonometric identity here as well. We know that cot square x equal to cosecant square x minus 1. Using that identity here, we can write cot square x as cosecant square x minus 1 into dx. And this can be split into two integrals like integral cosecant square x dx minus integral 1 dx is dx. And of course we know integral cosecant square x dx equal to minus cot x, and integral dx is equal to x. So this will get reduced to minus cot x minus x plus c. We can take a minus common from these two and write it as minus of cot x plus x plus c. Let us solve this sum. Integral sine square of x by 2 dx. We know one identity which states cos 2x equal to 1 minus 2 sine square x. Since there is half of the angle x by 2, changing this x to x by 2, we get 1 minus 2 sine square x by 2. This will eventually give you cos half of this 2x, which will be x. So cos x equal to 1 minus 2 sine square x by 2. So 2 sine square x by 2 will be equal to 1 minus cos x. So sine square x by 2 will be equal to 1 minus cos x divided by 2. Using this value for this sine square x by 2, we can write this integral as integral 1 minus cos x divided by 2 into dx. And this can be split into two terms like 1 by 2 minus cos x by 2 into dx. And this can be split into individual integrals like 1 by 2 dx minus integral cos x by 2 dx. Taking out the constants, we get 1 by 2 integral dx minus 1 by 2 integral cos x dx. And this will give us 1 by 2 into x minus 1 by 2 into integral of cos x is sin x plus c. If required, we can take this 2 common and write this terms combined as x minus sin x by 2 plus c. Let us solve this sum. Integral of root of 1 minus sin 2x dx. Even if we write this root of 1 minus sin 2x as 1 minus sin 2x power 1 by 2, we won't have any formula support for this. So we need to do some more trick to get rid of this square root. Let us see how we are going to achieve that. Consider this root of 1 minus sin 2x. We know one trigonometric identity which states that sin square x plus cos square x equal to 1. Replacing this 1 with sin square x plus cos square x, we can write this as square root of sin square x plus cos square x minus sin 2x. And we know the formula for sin 2x. Sin 2x equal to 2 sin x cos x. Replacing this sin 2x with that value, we get sin square x plus cos square x minus 2 sin x cos x. This value inside the square root resembles the expansion of a minus b whole square, which is a square plus b square minus 2ab. Replacing a with cos x and b with sin x, we can have cos x minus sin x whole square equal to cos square x plus sin square x minus 2 cos x sin x or sin x cos x. Both are same only. So we can write this value inside the root as cos x minus sin x whole square, and this square root and this square will cancel each other's effect, and we will have cos x minus sin x as the answer. So root of 1 minus sin 2x equal to cos x minus sin x. In this integral, we are going to replace root of 1 minus sin 2x with this value. So this integral will become integral of cos x minus sin x into dx. Splitting this further into two integrals, we have integral of cos x dx minus integral of sin x dx. Of course, we know integral of cos x is sin x minus integral of sin x is minus cos x plus c. Simplifying this further, this is equal to sin x plus cos x plus c. Let us take this sum, integral of 4 minus 5 cos x by sin square x into dx. First, let us split this into two values, like 4 by sin square x minus 5 cos x divided by sin square x into dx. Simplifying further, taking out the constants outside, we get 4 integral 1 by sin square x dx minus 5 integral cos x by sin square x dx. Simplifying further, we get this is equal to 4 into integral of 1 by sin square will become cosecant square x dx, right? Minus 5 integral of, we are going to split this into two terms further, like cos x by sin x into 1 by sin x into dx. Simplifying further, we get 4 times integral cosecant square x dx minus 5 integral cos x by sin x will become cot x, 1 by sin x will become cosecant x. So these two can be written as cosecant x cot x dx. And we know integral of cosecant square x dx equal to minus cot x, and integral of cosecant x cot x dx equal to minus cosecant x. So using these values, we get 4 into integral cosecant square gives you minus cot x, minus 5 into integral cosecant x cot x dx will give you minus cosecant x plus c. Further reducing, this will give you minus 4 cot x, minus into minus becomes plus 5 cosecant x plus c. Let us solve this sum, integral of 1 minus cos 2x by 1 plus cos 2x dx. We are going to use trigonometric identities here as well. We know that cos 2x equal to 1 minus 2 sin square x. So 2 sin square x will be equal to 1 minus cos 2x. And also we know cos 2x equal to 2 cos square x minus 1. Taking this minus 1 to the left side, we get 1 plus cos 2x equal to 2 cos square x. Using these two identities, we are going to write this integral as integral of 2 sin square x divided by 2 cos square x dx. These two 2's will get cancelled. Sin square by cos square will give you tan square x dx. And there is no formula support for this integral tan square as well. So we are going to use the identity which says tan square x equal to secant square x minus 1. This will give you integral of secant square x minus 1 into dx. Now we can split this into two integrals, like integral secant square x dx minus integral dx, and we know integral of secant square x dx equal to tan x, and integral of dx will be equal to x. So this can be written as tan x minus x plus c. You have learned solving some sums in this lecture. We will solve few more sums in our next lecture. That's all for this lecture. If you find this video useful, like it and share with your friends. Stay tuned for our upcoming videos. Thanks for watching.